Ancient technologies. Ancient humans had electricity way back in time. Even the ancient Egyptians had electricity. Even the civilizations before that. Right? So this video is to showcase, well, one, electricity, because ironically a lot of people don't know what electricity is. That's why I see this comment a lot of people complaining about paying for electricity. And when I point out, it's like, you don't need to pay for electricity. You can just make your own. Or you can, like, we don't need some type of nuclear fusion reactor to create electricity, because one, electricity is everywhere. We're made of electricity, because you gotta understand what electricity is. Electrons. Electricity is just a way of saying electrons moving from one point to another. So once you understand what electricity is, then you're like, oh, well, electricity is everywhere. Because I always hear this term of free energy, and people are like, oh, look, free energy. So now we don't have to pay for electricity. It's like, we never had to pay for electricity. We choose to pay for electricity because it's convenient. Instead of you going out of your way to make your own electricity, you pay an electric company to do it for you. That's what you're paying for. You're paying for them to provide you the electricity that they generated and they collected and they supply you. You're not paying for the electricity itself. You're not paying for electrons. One, you can't patent electrons. You can't patent electricity, but you can patent the technology used to harness, to collect, to attract or emit, whatever you want to call electricity. Anyway, so speaking of, battery, the concept of batteries, for example, is like the Baghdad battery, right? Once you understand, what a battery is and how a battery works, then you can understand, like, oh, it wouldn't be that hard to build one, even in ancient times. Baghdad batteries, literal physical proof of that. That all you need is some type of jar. And we know ancient humans made a whole bunch of jars out of clay and wood and stone. So it wouldn't be hard to make a jar, right? A container that you can put some type of liquid. And the liquid could be salt water. It could be electrolytes, right? Well, that's the term we use nowadays, electrolytes. In other words, lemon juice, anything kind of acidic that especially has citric acid, like lemons, right? Lemons. You can have water with baking soda will work. Water and sugar, water and salt. Like I said, salt water, seawater. So you get some ocean water, some salty water, or just some salt and water, mix it together, and you have an electrolyte. And then what you need in order to produce electricity, right, would be copper being one of the first materials you'll need. And then the other one can be zinc, can be iron. The thing with using iron is that it rusts more often than zinc. So that's why zinc would be a better choice. There's other types of metal you can do, but copper definitely is one of those metals you're going to need because it works better. It's a good conductor of electricity, and that's why we use it in our technology, as well as, you want to be able to use this electricity. So copper is one of the metals, and then you just need another metal that's opposite of copper, so that way the electrons can go from one to the other, right? Positive, negative. And like I said, once you understand what electricity is, you understand how easy it is to make. So I'm going to show you some videos to illustrate that concept. So this will be the Baghdad battery.
So almost certainly, this must mean.
That's what it looks like. See? Vinegar, red wine, basic grapes. So here's what a lemon battery looks like. So, which is basically the premise I was talking about. So at least 1 volt he was able to get, close to 1 volt. With a lot of lemons, obviously with a lot of lemons, you'll be able to produce way more electrical power. I've seen a video before about somebody that showed how to use limestone with some other chemical, like a chemical combined with limestone, and is able to produce electricity. And they were able to make a big 5-gallon, bucket battery. They were able to make a lot of electricity from that. Later on in the future, I will definitely revisit and try to find that video. But it was really interesting to see says like, oh yeah, with limestone, which ancient humans, especially Egyptians, had mixed with this other chemical that I forgot what it's called, which should be readily available at the time, was able to create electricity. But lemons, and you can import lemons. You could be like, oh, Egyptians didn't have lemon trees. Oh, well, they can import it. They can get lemons from countries that have lemons. But it doesn't have to be lemons, but that's an example. See how it's zinc, and then there's copper. The fact that a lemon itself can be used to make a battery lets you know that electricity is easy to come by. Alright, so he's going to obviously test out different materials, different. He found his vinegar was the best one. Let's see what's he got. Does he power something with this? Right. Oh yeah. So it was the idea of like, okay, what was so one they had batteries, but what did they use electricity for, right? Well, he says for metal plating, basically. So he's gonna try to put, he's gonna try to put copper onto it. So by putting in the chemical, by running electricity, now he electroplates the coin. And of course, so the idea was just to basically put, coat things with different metals like copper, gold, and do gold plating. So that was the idea. It was a way to attract these metal particles onto whatever you're trying to do. You're trying to put the metal onto. Let's go to the next thing. So then, the Nerf battery. Same process. Right, let me explain real quick. Same process of the whole metal, right? The copper, the zinc, metal, which are the most important part. That's where the electrons for the electricity come from. It's the metals, copper and zinc, for example, right? The electrolyte just allows the transfer of the electrons. That's what the electrolyte's for. And it could be lemon juice, for example. See how there's vinegar and water. So he's using vinegar and water. And I forgot how you make vinegar. There's videos on you can learn how to make vinegar. But ancient humans had vinegar. They obviously had salt, water, and stuff like that, right? So it wouldn't be that hard to come by. The vinegar is a little extra. He could have just went with salt water, but you get the point. And he's gonna put it into this little ice tray here. You see there's copper wires wrapped around metal nails. Those are steel nails, so he's using steel and copper. You see he's putting in dirt. That's the earth part of the battery part. Then he's going to obviously put in, he puts in the electrolyte, like the salt vinegar mixture, and he's going to start producing some electricity. See how there's a little bubbling over there? So there's obviously chemical reaction happening there. That's why there's bubbling. See the bubbles? So right now he's trying to make sure everything's all contacting. You see now there's some reaction. Oh, there's some power. 12 volts. See? You see the bubbling? And that's all it is, just chemistry, right? Basic chemistry. Ancient humans knew about chemistry, especially Egyptians. They all knew about chemistry. And of course, they could have used the same type of method with the Great Pyramid and used the Great Pyramid as a big, battery, using the water from the Nile River as their electrolyte. That would be for future video. Right now, I just want to show that, yes, they with some salt water, dirt, steel, or zinc, or iron and copper, you can make electricity. But again, just because they could make it, we don't know if they used it per se, but it's the idea that you definitely can make it. Right? So since you can make it, it's possible to actually for them to have used it.
Well, in a perfect world, these cans all have equal positive and negative charges, but usually one of them has a slight imbalance. Let's say this one happens to have more negative charges than positive charges, so it's negatively charged. Notice that it's wired up to this other can, so it's negatively charged too. Water falls into this one as a steady stream, but when it comes out, it's in the form of individual drops, filmed here at a higher than normal shutter speed so you can see each drop. That's something that streams naturally do after they've fallen a certain distance. The can is positioned so it's at the transition point. Since this can is negatively charged, that means negative charges in the water stream will be repelled. That's because like charges repel each other, and the only place they can go is back up into this container. That also means that the drops that fall away will be left with a positive charge. Those positively charged drops fall into this other can, making that can more positively charged. So the two cans sitting on the table are oppositely charged. Now notice that this positively charged can is wired up to this other can here, so that one's positively charged too. It also has a stream of water falling into it, and drops falling out of it. Since the can is positively charged, it repels positive charges up the stream and into this container. Or more precisely, it attracts those negative charges from the other stream to this container, across this aluminum foil, to this container, and down this stream. In either case, the drops that fall here are negatively charged, making that can more and more negatively charged. And the same applies to the continuously falling, positively charged drops on the other side, making that can more positively charged. So you now know that opposite charges build up on these two cans. And since these wires are connected to those cans, opposite charges also build up on both sides of this spark gap. When enough charge is built up, a spark occurs, and the charges try to equalize. After the spark occurs, everything is more neutral, but still imbalanced enough for it all to start over again. And that's how it works.
And that's it. And you get the idea, see? So even just with the flow of water and using copper wires, right? And you might notice that there's the tin cans, and because somebody tried to point that out to me, like, oh, ancient humans didn't have tin. It's like, well, that's incorrect. But at the same time, it's like we're not saying that they had tin specifically. You don't need tin to do this. You can use iron, you can use zinc, you can use any other metal besides copper, right? Because you need copper, but you also need a different metal. A metal that's different than copper. You definitely need copper. Ancient humans obviously had copper. You can use brass. Brass is copper and tin combined. Think about that. Just blew your mind there, right? Brass is copper and tin combined. It's an alloy. So yes, ancient humans had tin, but it was mixed with copper. But whatever. Maybe they found a way to separate the tin from the tin and the copper from the brass. And or they had tin, they had copper, and they decided, oh, let's put it together and make brass. Whatever. Point is, they had the materials. They could have done this. Is what I'm saying. And then something else. All these processes are the same. The only difference is the materials they're used. But a lot of the materials are pretty much the same. Here is a tree. A biological
shock, almost like an electric
fence, life form, right?
Fence or kettle fence.
Wow, really?
Yeah, so really. So I had the idea, I called my electrician and we measured, and in fact we could measure a current in the tree. Here, please, Fundi. You have to go in.
I'll let the full video play out.
And immediately
there's a lot of good information.
That you see, I'm not
it
joking.
Shows a lot of good example of what the tree can do.
This tree is currently delivering 25 volts DC. So one day, Fundi and me, we took our electrical wire. So just an electrical wire, round our tree, nicely, like that. Tight. Yeah, it helps if before you put your wire, you really scratch the skin of the tree, and it helps if you keep a distance between your wires. You see the scar in the tree?
Yeah.
Where the tree have those scars, that's where they produce the most of power, categorically. Yeah? So that is where you can get up to 280 volt, even AC. But lunchtime, when it requires full sun.
So we pause there for a little second. The reason he mentioned the whole lunchtime thing, noon and stuff, that's because it's high noon. That's when the moon is not moon, the sun is the highest and the brightest and the most energy. Because essentially, what he's showing us here is a solar plant, literally, right? Solar plant. It's because it's a plant, it's a tree, obviously, and tree are living life forms. They create electricity, of course, and what they do is they convert sunlight into into electricity, essentially, right? So these are essentially natural solar panels. Is what I'm trying to say. So right, solar plants, solar panels. So these pretty cool. So we already have a natural solar power through the powers of tree. Let me pause it for a second. We humans are also solar powered in a way. We don't use the when the sun hits us, we don't use it the exact same way trees do, like plants and stuff, but we do use solar energy in a different form, and we get vitamin D from the sun. But that's some medical science stuff for some other time. But yeah, we are solar powered as much as plants are, just in a different way.
Electrical connectors. Now we should be able to measure the current, or we can run a light bulb or a grinder, which we are going to do for you in a second. Okay? So now, of course, I have both wires on. So here, careful. You see that? This is now 220 volt DC. You can check here, there is no wires going to the tree or whatsoever.
That's a LED light bulb. Yeah, it's funny he's mentioning, how much voltage and stuff like that. Like 200 and something. It's like, oh yeah, you could charge a laptop. You could run a microwave with that. But that's an LCD light bulb, which uses way less electricity. It probably uses like maybe 25 to 30 volts, which you saw the meters showed 25 volts earlier, but right now you're saying 200 something. But that's just, a little pointing that out,
Before we figured that in the day we can run a grinder and in the night we can run a light bulb. All our security lights here in our shop, everything here runs off these trees. Now we connect the angle grinder. Here, please connect it for me. So, now you can see it is 2 o'clock lunchtime, bright sunlight. Yeah? So, we will see if we get now an angle grinder to run. Yeah! Now here, oh, this is now serious power, guys. Yeah? This is serious power. Light on. You can charge batteries and you can charge phones. Sign up! Everyone can charge their phones here for free.
This was cute. Because everybody wants to charge their phone. See, I put right there, natural solar panel. That's essentially what it is. That's all it really is. That's all he's really pointing out. Is that was a, trees, function a lot like a solar panel. Solar panels are actually inspired. As I said, solar panels are inspired by trees. Somebody was trying to create essentially photosynthesis, right? Way to convert photons, light energy into electrical energy. Electric panels were, solar panels were created. So that's the thing. It's like we're just going reverse right now. He's just like, yeah, tree during noon when the sun is out, and charge your phone with a tree. And it's like, yeah, that's a natural solar panel. Yeah, that's all it is. And yes, ancient humans had trees, sun. So why wouldn't they? And they had copper wires, right? Because they had copper tools and whatnot. They could have done this. So the main point is, my next video will be about hydrogen gas, like what they use electricity for. Because, I already explained, it's not that hard to get electricity. You could rub your wool or some type of cotton material against your hair, right? And then you could create static electricity. So there's there's a way you can create electricity with wool and copper. Like if we rub wool, like sheep's wool, on a copper plate, it creates static electricity, and that's one way of creating an electric generator.
On the table here in front of me, I have a piece of rock.
I have
This looks like
another
ordinary
thing.
rock, but it's actually special rock.
Here,
It's
let me
called iron
show.
ore. There is some iron mixed inside this
Lodestone.
rock. It's actually called lodestone, so it's a natural name. Now, this rock, somewhere in its past, was struck by lightning, and the
Known as a
electricity running through it
lodestone.
has changed the properties of the iron inside, and it's given it the ability to attract other pieces of iron like this. As you can see, now this is a property known as magnetism. So the lightning strike, the electricity flowing through the rock, has turned this into a naturally
Natural
occurring
magnet.
So lodestones are the first magnets we ever found. How does that work? Well, turns out that these naturally occurring magnets can be created by lightning because we can make our own magnets as well. The way you might
Ancient humans had magnets because ancient humans had lightning.
You might have a slightly different looking one at home, but you'll need a bar magnet and something made of iron. I'm going to use a simple nail like this. You'll probably find out in the shed. What you need to do is stroke the magnet along the nail like this in the same direction all the time. Don't go backwards and forwards. It has to be in the same direction.
But the funny thing is, he could have used the lodestone to do this because the lodestone already is a magnet. So he could have just rubbed the nail against that and turned that nail into a magnet.
This nail has been permanently magnetized by that stroking with the magnet. So we can make our own magnets at home. Very easy to do. The other thing, of course, we can do is we can actually make something called an electromagnet. Now, I said that lightning, that flow of electricity, has magnetized the rock because when electricity flows, it makes magnetism. So over here on the table, I've got two really, really big coils of wire, lots and lots of wire coiled round and round and round in a big spiral. When I push the switch on this table here, it puts some electricity through those coils, and when I do that, you might hear the hum coming from that now as there's electricity flowing through them. These bits of metal here.
Yeah, of course. We already know how to make a electromagnet, but the opposite of that, right, is creating electricity. What you'll need is a magnet, like the lodestone, for example. Have it spinning. Wouldn't be that hard to have it spin. You just tie it to a stick, and then have the stick spin, right? Rotate vertically. I said it wrong. Horizontally, and then so like I said, you'll be using copper coiled up, and then you take the lodestone, which is a magnetic rock, and have it pass through it back and forth or spin it while surrounded by copper, and you can create electricity. But what would they use the electricity for? Well, making hydrogen gas. By putting the electricity flowing, having it flow through the water, it'll separate the hydrogen from the oxygen. Now you have hydrogen gas. And you can use hydrogen gas to do a whole bunch of other stuff. That'll be the hydrogen video, so I'll explain more later. Just wanted to point that out. But ancient humans definitely had access to electricity because they had access to water. I mean, electrolytes and stuff, but they had access to electrons from everything. They had metal. That's the main thing that we use to do a lot of our electric stuff, like our technology is based off of metal and using the electrons from the metal. That's where electricity comes from.